Hey guys, welcome back to Data Products with R. In this video, we're going to be going over covariation. So what is covariation? So if variation describes the behavior within a variable, then covariation describes the behavior between two variables. And so covariation is the tendency for the variables of two or more data sets, two or more variables, I should say, to vary together in a related way. So this would be like a direct correlation, either positive or negative. So the best way to spot this is to visualize it. So we'll be doing this visualization. And the reason that you'll want to do this visualization is because, understand if they're covariates, is because if you do linear modeling or GLMs or any sort of multivariate modeling, then covariation will mess up your model because there is attempting for these models to attribute some sort of underlying purpose or underlying explainability to one variable can't be distinguished from another if they correlate perfectly, if that makes sense. So if you have something like height and body weight are generally positively correlated. So if you did a model that was trying to determine if somebody eats more and two of your explaining variables were height and body weight, well, they're so tightly correlated that'd be very difficult to pull them apart and to determine which one is causing the person to eat more. That's kind of an off the top of my head example here. Excuse me. So you have to go about, we're not going to get into the alternative ways. That's kind of for a stats class of how you might deal with covariation, and it's kind of a nebulous topic where there's not a lot of perfect solutions for it, but it's information that's really pertinent to know before you start doing some sort of modeling based on your data set. So without rambling too much further, let's go ahead and get into it. All right. Let's open up RStudio, and we'll make a new R Markdown file. We'll call this covariation. Yeah, let's get rid of all this preamble stuff. So the first thing we're going to do is we're going to load a library, and we're going to load ggplot2. And then we're going to do ggplot data equals, we're going to use the diamonds data set. Mapping equals aesthetic, x equals price, we'll have price on the x-axis, and then we're going to say geom free poly, so frequency plot. Mapping for this equals an aesthetic where color, oh my goodness, color equals cut, and then bin width, wow, my typing tonight, equals 500. Okay, so first thing we're going to do, geom freak poly, Mr. Q. Okay, so frequency poly. So in this case, we have a frequency distribution of diamonds based on whether they are fair quality, good quality, very good quality, premium quality, or ideal quality. And so we have a frequency of the price of these things. So you see that for ideal qualities, we have a ton of them that are priced at this much. For premium, we have a premium that is priced a peak here, etc. But this doesn't give us a ton of information. So it's hard to see the difference in distribution because the counts differ so much. So if you were to analyze the area under the curve, you'd see that there is a big difference. And so what we're going to do instead, we're going to do ggplot diamonds, and let's look at geom bar mapping equals aesthetic. We're going to do x equals cut. So we're just going to look at the distribution. So you can see that we have a ton more that are rated as ideal less premier, less very good cut, some good, very few fair, because you know you've got your fiance, well, your potential fiance, and you're going to buy her a ring. You don't want to, you know, buy her a fair ring. You're madly in love, so you're looking for this ideal ring. So there's just many more ideal cuts, and maybe it's a product of, okay, you know, we're not going to sell fair diamonds because they always have these like certificates of evaluation or whatever. So if I was like, oh, I love my wife so much, I want to, or my potential fiance, this woman I'm going to ask to marry, let me buy her a fair diamond. You know. So, anyways, moving on. Okay. Let's annotate. To make the comparison easier, we need to swap the display. Oh wait. Yep. Display on. Oops. On the y-axis. So instead of displaying count, we'll display density, which is the count standardized, so that the area under the curve is 1. So what we can do is we can standardize and kind of average it, right? So this is based on just total counts, right? But if we make everything equal by standardizing it and say, okay, what percentage of these are the price is fair, etc. So we're dividing everything by itself to kind of get a percentage of itself. So let's do this. ggplot data equals diamonds, mapping equals aesthetic, x equals price, y equals ... density ... and geom freak poly, mapping equals aesthetic, color equals cut, bin width equals 500. Okay, so now by using this, you can see we've changed this graph. So before, you can see that yellow was super high, green was at around, was that 3,000? But now we've standardized this density so that we can compare it better. So they're all normalized to each other. So this distribution of sample size is gone. So we can kind of say, all right, what percentage of them are, you know, at the price of, you know, $1,000, etc. And you might ask, okay, well, this is based on cut. So how symmetrical the diamond is, how good the cut is, right? So you might be like, well, how are the ideal cuts, you know, the most ideal cuts and the most premier cuts and the most very good cuts are all the highest frequency? Well, it's because there's other things involved, right? So you have cut, carat, color, and clarity. So my wife, the other Dr. Vandenbrink, actually used to work in a jewelry store, so I know all about this. It made picking out a ring very difficult. Actually, I'm going to have a little side here. So because she worked at a jewelry store when I was going to ask her to marry me, it was bad and it was good. Because it was bad because she knew a ton about diamonds and a ton about rings. So by proxy, I learned about a lot about diamonds, a lot about rings. But also, I got to know the jewelry store owner, so I was able to, he actually went to Bruges and picked out a ring perfect for the design. We actually had it custom designed and made a very cool ring for her. So anyways, so the reason that that's, you know, a little delve into my life and knowledge of diamonds. But the reason that Ideal Premier, there's so much here is because other things, right? You can have an ideal diamond that is really small that can be priced the same as a good diamond that's much bigger. So that's why, if you're curious about that. Okay, where was I? So So it appears that fair diamonds, which are the lowest cut quality, have the highest. Oh no, sorry, I'm getting ahead of myself. Let's see. Oh yeah, right. No, that's right. Sorry. It appears that fair diamonds, the lowest cut quality, have the highest average price. And I think the reason we get this conclusion, right, is because looking at this distribution where you would draw the average of the distribution, for these you'd probably draw them for like good, very good, premium, ideal. You'd probably draw it somewhere right here, right? It's close to these peaks because that's the majority. But for the fair diamonds, the average is much closer to here of this purple line distribution, right? But maybe that's because frequency polygons are a little hard to interpret. So we can look at it another way. So another alternative is the box plot. So a box plot is a type of visual shorthand. So we've gone over box plots, but we're going to characterize it here. For a distribution of values. Okay, so let's do, oops, put an R in here. So let's do a box plot of it and see what we see. So ggplot data equals diamonds, mapping equals aesthetic, x equals cut, y equals price, and then we're going to add geom box plot. Diamonds mapping equals aesthetic, x equals cut, y equals price. What did I? And geom box plot. What's wrong here? Data equals diamonds. Mapping equals aesthetic. X equals. Oh. Wait. Data equals diamonds. Mapping equals aesthetic. X equals cut, comma, y equals price. Geom box plot. Why are you not working? Oh. Duh. There we go. All right. So from this we can see the average price. So we see that, again, we're still representing fair as the highest average price, right? And then we have good, then, so I guess the highest would be premium, if I line that up right, then fair, then good, then very good, then ideal is the lowest price, surprisingly. But that's another way to look at it. So we see much less information about the distribution, but the box plots are much more compact, so we can more easily compare them. So it's easier to compare this than it is this, where they're all overlapping, right? So you can kind of see where their averages are. So it supports the counterintuitive finding that better quality diamonds are cheaper on average. So that's just our data. So ideal diamonds for the cut, but remember this isn't based. So this is if you only based on cut. You're not taking into account carrot color or carrot color, cut, and now I can't even think of the fourth one. You're probably screaming it at me right now. All right, moving on. Okay, so if you have categorical variables, so we have them lined up, right? Fair, good, very good, premium, and ideal. Let's load a different data set just to show how you can reorder things based on average. Because this makes sense, right? Fair, good, very good, premium, ideal. That's kind of like a hierarchical, intuitive ranking system. So let's load, let's look at some car data. Car. And this is just to show you that, you know, whatever biological ranking you're doing, you can reorder it on your graph. And so let's do ggplot data equals mpg, mapping equals aesthetic, x equals class, y equals hwy, which is highway, and then geom box plot. So this is just a short example of how you can reorder these variables. So you see here we have our average highway mileage, and then we have two-seater, compact, midsize, minivan, pickup, subcompact, SUV. So say we wanted to reorder these based on their actual miles per gallon. What we could do is we could go, just to make our graph more intuitive, because this makes sense because they're in order, but if this doesn't matter, then it might be better to have it aesthetically have them all line up in an ascending or descending order. So what we would do is ggplot, let's see, data equals mpg, and then we're going to say geom box plot, mapping equals aesthetic, x equals reorder, class. So we're going to reorder the class, which is our x-axis, and we're going to reorder it by highway. Our function is of that highway variable is going to be the median, and then our y is going to be the highway. Okay, so if we run this, then we see just what we wanted. So we have the lowest mile per gallon for the highway is a pickup, then an SUV, then a minivan, then a two-seater, then a subcompact, compact, and a midsize. So this makes more intuitive sense if you were to graph it that way, right? So if you have some sort of biological variable where it's like dosage or exposure or something like that, you can reorder it using the reorder function. Okay, so if you have long variable names, you can switch the axis and flip it 90 degrees. So let's do ggplot data equals map, or no, mpg, sorry, geom box plot, mapping equals aesthetic, x equals reorder, class, highway, function equals median. We'll do median instead of mean. Oh no, we did median last time. We could do mean as well if you wanted to. Y equals highway, and then we're going to add a function called chord flip. So it's just going to flip the two axes. So you can see here we just flipped the x and the y, so we have pickup, etc. Cool little trick if you're interested in doing that. Okay, so all of this stuff, I forgot to put at the top, but all this stuff is categorical variables, right? So covariation is really difficult in categorical variables, right? So you can see like there's kind of a relationship, but it's more important. Well, I don't want to say more important. A statistician will come and hunt me down if I say that. But it's easier to identify, and it can be, in my experience, has affected me more with not categorical variables. So with numeric variables, right? So let's see. Let's do visualize the correlation between two numeric variables. You'll need to count the, well, actually, sorry, we'll use continuous, it's probably better. Two continuous variables, you can use a scatter plot. So, let's do ggplot data equals diamonds, and now let's do a correlation between x equals carat and y equals price. So the carat, or the weight of the diamond, can be any number from 0 to infinity. You could have the world's biggest diamond, I guess, or a moon-sized diamond. And the price can be 0 to infinity. And so if we do this graph, you can see that there's a direct correlation, right? And so the bigger the carat, the higher the price. So if you were trying to explain to somebody, say we were trying to determine, say you're financing this diamond. You went to the jewelry store and said, I need a loan for this diamond. And so we took all this loan data. And we said, okay, what is contributing to the size of the loan? Is it, and two of our variables are carat, or the size, and the second one is the price of the diamond. Well, both of those things are related, right? So because the size is bigger, the price is bigger. And if the size is smaller, the price is smaller. So for you to determine, okay, is it the price or is it the size that is contributing to how much this person had to take out in a loan, you wouldn't be able to distinguish them because they're directly correlated, and that's what we see here. And so this would be an example of like high covariation. So if you're doing a model like that, where you're trying to do like a linear model between the different, or explaining loan amount based on price, it's probably not the best thing, the best example. But between the loan amount and you're explaining, or your variables explaining the loan amount, where the price and the carat, there's covariation there. So you wouldn't be able to tell the two apart. Okay, rambling again. So the last thing I want to do, so if you have a really big data set, you kind of get just this ink blot, right? Where you get just a whole bunch of black. And so we can kind of tidy this up. So scatter plots become less useful as the size of your data set grows, because we get overplot, is what it's called. And so we can fix this using the alpha aesthetic. So I think we've talked about alpha before, so that's like transparency, right? So what you set your alpha to. So if we do data equals diamonds, geom point mapping equals aesthetic, x equals carat, y equals price, and then our alpha equals, we're going to say 1/100th. So if you run this now, you can see that what it just does is, because there might be plots like in this area, there could be like 1,000 plots in this area, right? But you'd never know, because black is black. So if there's one plot, or if there's 100 plots on top of each other, you can't tell the difference. Well, what this does is it gets rid of that, right? So like the lightest color, you can see like right here, if you look real close, that looks like it's probably one count. So the more and more counts that you add on top of it, the darker and darker it gets. So you can see that there's like a ton over here that are all just layered on top of each other. But when you get up to these points out here, there's a lot less. So it helps you kind of visualize the depth of the scatter plot, right? Okay. So I kind of went on a rant this class. Covariation, very important preliminary data analysis step to take if you're thinking about doing modeling, because if you're doing, like I said, GLM, any sort of linear or, for that matter, nonlinear modeling, it can mess up your model, and you'll have to take different approaches. We're not going to get into the different approaches. That's a huge quagmire. They're out there, but it's just beyond this lecture or this course, for that matter. It's kind of a statistics thing. I wrote a paper with some collaborators on autism, looking at genes, and if there's a correlation between autism diagnosis and the certain genes that they found alterations in. There's a ton of covariation, and it became this big thing. So I'm had horror stories. So before you go down that road of statistical analysis and getting crazy into developing these models, know that covariation is something you should look at early to determine if these input variables are going to be safe in your model. So with that being said, just something to keep in mind when you're doing preliminary data analysis. Our graphing tools that we've learned throughout this course are perfect for being able to look at this. I hope you learned something. I hope you were able to kind of, on top of this stuff, the graphing is very helpful. You can also do correlations as well. So we didn't do like R squared values or R values, but you can do that as well. Visualization kind of just helps you, because your R values can be affected by outliers and things like that. So visualization really gives you a better idea of how correlated your values are. All right, no more rambling. 27 minutes. This is a long one already. So with that said, if you're watching on YouTube, please hit like, please hit subscribe. We're going to be pumping out more videos. I hope you enjoyed this. Stick around. We're going to be doing an actual walkthrough of all this exploratory data analysis. And with that, I will see you in the next one.